What's good, guys? Welcome back to Period 7, Miss Leg. We're gonna do some math. So Miss Leg's behind the camera, so we're gonna head out and do this math. Let's go.
Let's go. What's that transition?
Did you stop the video? No. I hope she did it. No, it's not recording. Yeah.
Alright, we are beginning, we are rolling, we are beginning. And I've already heard some requests that I will address. I'm getting some requests like, hey, can we just have a rest period because it's the last day of the quarter? And while I totally get it, if I were sitting in your seat right now and I were a student, I would want the same thing. And if I were not so good of a teacher, I'd be like, that sounds awesome. Let's just rest the day before you have a 4-day weekend.
That's the best idea ever.
Again, that if I were not so good, okay? But because I care, I'm gonna make you work for your 4-day weekend.
Wait, on? We're gonna work on that?
No, I'm gonna make you work for it. Like, you do what you need to do in class today, you get your 4-day weekend. You don't do it, I assign you lots of homework to complete over your 4-day weekend. Does that sound fair?
No.
Okay, so would you like to have a rest day and lots of homework over the weekend? Or would you like to have a...
Wait, there's homework? No, I just tuned in now.
If you're just tuning in, we will be going over the topic 3 Readiness Assessment. Why would we go over something like that? What does readiness mean? It comes from the word ready. Because we want to be ready for what?
Topic 3.
Topic 3. Judging by the results, I'm going to need all voices off. You know that when I get to the end of the day, I am tired. And when I have to talk over you, I get even more tired and extra cranky, okay? Don't make me do that. So listen, voices off. We are going over it because judging by what I saw on your readiness test results, we have a lot of gaps to fill in order for you guys to be ready to start topic 3. And I know it would be nice if we could just rest and hang, but that's not what this class period is for. I'm not making you do any extra work, I'm just reviewing what you guys saw yesterday on your topic readiness, and I'm filming it so that if you need help over the weekend and you want to get extra ready, you can go over it. Or if somebody was absent, they can watch it.
Or if kids just want to watch it.
Yeah. I went through the data and I pulled out a little more than half of the readiness test, the questions that either more than half or like most to all people got wrong, okay? Those are the ones that I'm gonna focus on. Then, what I did in my 3rd period intensive math class was I went over the rest of them. The ones that either half the class got right or only a few people got wrong. I went over that in intensive math and I filmed it. So if you are one of the people who got one wrong that I don't go over in this class period, watch the other video to get review on those. Yeah? No worries. If you didn't complete it, you can still get a review because, again, I'm going by the majority of the class. Do you guys know what a majority is? What is a majority?
Most of it.
Most of it. More than half, right? So, if you're like, yeah, but I didn't take the test, so how does this review apply to me? Because I'm going with the majority. And what is the likelihood of being in the majority? Is it more likely to be in the majority or not? In the majority.
Likely.
So should you pay attention to this even if you didn't take the readiness test?
Yes.
Wonderful. So can we begin, please? Now, do you think reviewing this, you should have nothing out on your desk, or you should have your notebook open?
Notebook open.
And your pencil in your hand. Thank you.
Assessment one program. Question.
Yeah.
So we like have
Readiness assessment was for a grade?
like obligated
Tell me why I don't like the sound of that question.
Oh.
guys really don't want to hear, do we like have to take notes or is it like optional? Why don't we pretend that note taking is always mandatory and that your final grade of passing this course rests on it? And then let's just take some notes. I mean, you have to sit here anyway. You might as well take some notes, okay? We are going, what? It is not for a grade, but pretend that note taking is. Heck, maybe I will grade your notes at the end of the class. Maybe I won't.
Well, you saying that?
No,
Yeah,
Good there.
It's like,
If I grade them, it'll go as a participation grade, which wouldn't affect really anything.
Oh,
But I'm
I
not
have
gonna do that. I
74.
didn't do that for my classes. Just take notes because you want to take notes. Because you actually can, okay? Oh, hi. You said yes?
Yeah.
Okay.
I forgot which one we have.
Oh, here comes
Okay.
trouble.
Can you find it? You wanna sit? Yeah, you can be the teacher. It's a very squeaky chair, so don't knock that to work.
Teacher just
I have a
said
question.
Is it important for this?
Yeah, it's kind of like, instead of going, can I go back and look at it? I probably won't understand a single thing. This all confusing.
So you don't want to stay in here because you
No,
don't
I do.
understand it?
I'm saying like during Spanish, can I like?
Oh, like next period?
Yeah.
I'm not teaching class next period. You thought I was gonna teach this again?
Yeah.
No.
It's on the pressure.
No, sorry. I thought you were asking, can I go out there because I'm not gonna understand this anyway, so can I just leave? I was like, how is that?
Can I?
No.
Can I go get some water?
No.
We are beginning, we're already filming, so we need to focus. So, like I said, there is a whole other video that's gonna go over the questions that I don't cover today. But this video will go over this. Question number 1 is probably the hardest question on this readiness test. And of course, they gave it to you first, just to kind of scare you. Question number 1 is the hardest. In the group of ordered pairs, which are these cute little things right here, they are pairs in order from X to Y, right? X and Y. The X values are inputs, and the Y values are outputs. They're giving you some information there. Our X values are our inputs, and our Y values are the outputs. Have you guys heard of those terms before for X and Y?
yes.
Input
I
and
hardly
output.
remember them from last
Yeah, that's okay. I'm gonna change my marker, guys.
It's like,
Did you guys see that?
Yes.
Got it.
Fours.
Yeah. Yeah, just
No.
hurry and quietly and don't go that way. Don't go that way. Just go the other way because it's gonna mess with the camera.
I just asked you to
You can fall on the ground, I bet you see. You're gonna fall on the ground in the back.
I asked you to water, you said no.
Here's the bathroom, it's different. It's going the other way. All right, you go get water. Go.
I'm just waiting.
Okay. All right, so we've got inputs and we've got outputs. Guys, are you with me?
Yes.
We have
I'm taking
inputs and
notes.
outputs.
I'm trying to take some notes.
We need to organize these pairs in order to answer the question. Get it? Ordered pairs. Aren't you guys getting here right? All right.
You're
In
welcome.
order to organize these ordered pairs, let's put them in an XY table or an input-output table. So our X values will go in this column and our Y values will go in this column. So let's do it. 2, 4, 2, 4, 6, 3, 3, 5, 4, 7, 3, and 8, 2.
8, 2.
Yep, 8, 2. So you should be holding your calculators, you should be writing that down. You need to be writing down what I'm writing, okay? Thank you. So I've got it all organized, I still have my ordered pairs, I just put them in a table, right? Okay. Now that these are organized, let's start answering these questions. They are going to sound confusing. I'm even going to rearrange the wording of some of these sentences to make it easier to understand. The first one says, Now, it says select all the statements that are true, so we have to decide 5 times. It's really like 5 questions in one, right? 5 sentences that we have to determine, is it true or false?
Well, let's find out.
Okay, is it true or false? This says there is only one input for every output.
True.
Explain that. Okay.
There's a 2, there's a 4, there's a 6, there's a 3, and it's like all even, there's an even amount each.
Okay, so let me rearrange this sentence because it actually helps me understand it better when I rearrange it. Do you agree that I can say there's only one input for every output, and that's the same thing as for every output, there is only one input, right?
So like if you put something in the box, you can only take one thing out of the box.
Yep. For every output, there is only one input. And so what you just said, Brianna, is actually true, but you're talking about putting something in and only one thing coming out.
It's kind of like input output and just.
But the only thing is they're actually talking about the output as like, they're almost like switching the input and the output, and I'll explain. For every output, there is only one input. So if I'm dealing with the output is y. Why did I make such a long? Y. For every output, there is only one input. So I can only have one input for every output. All right, let's take one of my outputs, okay? 4. Check out when my output is 4, what is my input?
2.
2, very good. Is that the only input that I can have if my output is 4?
No.
Oh, I have an output of 4 over here too. I have another
That's
input.
what you need.
So it's confusing, right? But if you notice that my output 4 actually has 2 different inputs, making this statement false, right? Now, it says there is only one output for every input.
Wrong.
Let's see if that's true. I'm gonna rewrite it. For every input, there is only one
That's actually true.
output. It is. It is true. It's true. For every input, there is only one output. The way that we can actually see that pretty easily is we notice that there are no repeats in our input. If there are no repeats, then there's no way that you can get a different output. There's no way you can get a different output for 2 because 2 only shows up one time. So this is true. You wanna know how I can easily make this false? Watch what I do. Let's say I add an ordered pair and I say, I'm gonna add the ordered pair 8, 1. That means that the input 8 is giving me 2 different outputs. Then this would be false. But since there's only the input, you only see it one time, and for every time I input a 2, I'm only getting a 4 and nothing else. Every time I input a 6, I'm only getting a 3 and nothing else. It's okay that when I input a 7, I'm also getting a 3, because that's not what this is saying.
Like
It says for every input, every individual input, every time I put in a 2, how many outputs am I getting? 1.
So like with 7, would that still be true? Because
It would be true, it's these make this one false. For every output, there's supposed to be only one input, but there's 2 inputs for this output. The output 3 is reading 2 different inputs, and that's why this is false. But for the inputs, I have a 2, a 6, a 5, a 7, and 8. I don't have any repeating numbers. So every time I put in one of those inputs, I'm getting only one output. So that's true. And I know that this is hard. This is very, very hard if it's confusing to you. Please know that it confuses me too. I think really hard about this stuff. There is more, let's go to the next one. There is more than one output for some inputs.
Yes.
Yes.
There is more than one output for some inputs.
No.
Yes.
Yes.
There's more than one output for some.
So you think it's true or false? There is
That's true.
more than one output for some inputs. Okay,
Yes.
give me an example of an input that has more than one
I got you.
output. Tell me what the input is.
The input 2.
So tell me where I'm getting more than one output for the number 2. I put a 2 into
Because-
the machine and it came out 4.
Yeah.
If I put another 2 into the machine, is it coming out a different number?
Oh, no.
No.
I thought it was saying.
I love that you said that because that helped us give an example of why it actually is not true.
I thought it was because like because I thought it was
It's
saying like.
confusing because you see the 4 over here and the 4 over here.
That's what I thought. That's why I
Yeah.
thought I meant like there's two like.
It's
fours.
that's
I'm
why
like,
it
it's
is
correct.
super confusing. So this is false.
That's confusing.
It is. Okay, now let's look at this. There is more than one input for some outputs.
Yeah.
That's true because we proved that over here. There is more than one input for some outputs. Here's an output, right? Isn't this an output? This is an output. Are there more than one input for this output? Yeah, there's more than one input. Just go low or it's just.
I just don't want to hit that.
Okay. So this is true. And for the last one.
Wrong. I'm just an educated guess. It's wrong.
Okay. The group of ordered pairs represents a function.
It's false. Was that correct? Are you reading that for yourself?
Yes. I need it. I need to
Oh,
figure it out.
go.
These questions bum me out.
No.
All right.
Did you really?
Yeah.
Okay. The group of ordered pairs represents a function. How do we define a function in terms of the input and output?
Oh,
Yeah.
no.
No.
So basically, a specific number is targeted to a specific output. And like, but sometimes there's more than one output, even though there's a different X input.
Yep.
So like,
So this is true because each input only has one output. That's a function. You guys get it, kind of?
What's a function?
A function is defined by having only one output for each input. Like when you put in a 2, it's always going to come out a 4. If I added a pair here and it said 2, 6, that would not be a function.
Because it has
But
two
you don't measure it
inputs.
from like output to.
Correct.
Think of it as like a machine that like makes jeans and like
Genies?
That's what this stuff says at last.
yeah, and like one is making jeans that are like old timey and like they have rips in them. All the other one is making them look like they're brand new. And if both of them are making brand new things at the same time, who's gonna make the other pair?
All right. Select all the statements that are true of the relation. We have the exact same numbers here. This one is much easier to figure out, I promise. There are only 2 right answers. Select all the statements that are true of the relation. Now,
Oh, I think I know what that is.
what are the domain and the range? No.
The range is not like the y values,
Uh-huh.
and then the domain is all the x values.
Yep. The domain is your x, and the range is your y. So we've already talked about how x is also called the input. Now it's also called the domain. So there are 3 words that all mean the same thing. X, domain, and input. For your y value, it's also called your range or your output. Okay?
Yeah, I was stuck on this.
Oh, goodness.
No, it hurts.
You
Oh,
don't.
do not think
It's
to.
like-
I mean, do not.
I want to forget it. Okay. If the domain is all of your x values, yeah.
Both.
Abby should come back. If the domain is all of your then let's name all of our x values. 2, 6, 5, 7, 8.
1 million.
Which one matches?
None of them.
No,
None of them match.
Oh, wait.
A, but what's different about A?
It's in a different order. It's
a
in
different
least the greatest.
So this is correct. When you write the number set for a domain or a range, you always put it in order from least to greatest, and you don't repeat numbers.
Will it say like greatest to least?
No, it's
It's-
assumed.
Or
It's
it's
implied.
just always gonna be?
Always gonna be least to greatest. Now, for the range, I'm gonna circle our range. 4, 3, 4, 3, 2. Least to greatest, no repeats. So what would that be, Carmen?
The range would be 2 through 4.
Very good. That's it.
You know how I know that, Miss Lake?
How?
Math.
It's gonna say, because I just taught you.
That's genius.
Can I just talk about pencil?
Yeah.
Can I eat the whiteboard?
Yeah, right?
Moving on. No, Bo, please, Bo, sit down. Walk around, sit down. Guys, I wanna get through all of this, so you have it. And are ready to go when we come back from our little 4-day break.
Yay!
Shh. How many y values are there for
One.
each x value?
1.
1 is correct. And we can do this simply by the vertical line test. This is also a test to determine whether what you see on the graph is a function.
You wanna white?
There's only one output,
For every
y
input.
value for every input. So a linear function is a function because it's never going to loop around and have a second value for y.
You also wanna know why it's
So a
one?
vertical line test, if the vertical line only intersects the relation once, no matter where the vertical line is,
Oh, wait.
it only intersects it one time, then it's a function.
How would it intersect it twice?
Yeah, but can't you draw each of
So
them?
if I were to draw a relation like this, if I do something like that, this is a relation, it's not a function.
You also wanna know why it's one?
What?
Because you see the line that's right there, you also wanna know why it's one?
What?
Because it only goes to one line.
Yeah, exactly. Okay, so something like this, it's not a function, but it's technically a relation. There is a relationship between x and y. It's not a function. In the vertical line test, a vertical line would hit it twice. So therefore, it's not a function. There's too much noise. I'm listening to somebody right now and I can't hear him.
I was thinking this for the first one. I figured you could draw like infinite vertical lines, so it was infinite.
Oh, infinite vertical lines. No, the vertical line test is just one vertical line, and you can move the vertical line and test it again, but they're separate tests.
Yeah, but like how? What is infinitely many? What's like a straight vertical?
Yes, really good question over here. He said, what would infinitely many be? It would simply be any
Perfectly straight.
line that is vertical,
So wait, I have.
because it would have infinitely many intersections.
I have two questions.
Yeah.
One, why would it be infinitely many when it's just a straight line? It's not even going through a line.
Because, okay, let's see it, let's say the value is negative, of x is -2 over here, right?
Yeah.
How many values are there for y if x is -2?
-4.
Let's pick a couple of points. Let's just pick four points. There should be -2, 0, -2, 1, -2, 2,
And I go,
-2, 3.
I'm supposed to
Could I
say-
go on for an infinitely many amount of times?
Yeah,
Number of
maybe.
times?
I also
Yeah,
have a second
that would be
question.
infinitely many.
I also have a question.
Yeah.
What would it be if it's 0?
Wait, so what was the answer to that one?
And it wouldn't,
It's 1.
1, right?
1.
So then what would it be if it's like 0 though? Cause then,
It has to zero, it would have to have.
yeah, it has to end it, so I don't understand why zero.
I don't know. Maybe just a straight jump. All right, so number, okay, this one's pretty easy. Determine everything that's true. We're determining if it's true or false. Yes?
Can I go to the bathroom? Why does everybody need to go to the bathroom, bro?
Everyone's
Sure, it's just, the only thing is that I'm just teaching, but, yeah, sorry, I don't mean to single you out, because it's just that you're like the 10th person that's asking me, I'm trying to, I never know if it's a real emergency or not, because everybody seems to have emergencies during my class, so, don't worry, I don't take it personally and cry at night.
Well, I drink water. Right there, right there.
I hear.
So can I go bathroom?
No.
Go take another sip and you'll be fine.
So I'm not even joking, I do need to go.
That's fine. Can I continue?
Yes, ma'am.
Determine if this is true or false. Some input values, what's input? Faith, what? It's okay. It's okay. Good. I love that she said I have to look at my notes. She paused, looked at her notes, she's taking good notes. All right. And I'll give you, because technically you did answer the question. Okay. Some input values, some x values are negative. Is this true or false?
True.
True.
Yep. Because all of these points, and continuing on, will have negative x values. Some output values are negative.
No.
True? Can you find a point anywhere on this line and getting negative y value?
Yes.
Yeah.
Yeah, lots of them, right?
Yeah.
Like all of these so far, right?
What's the question for this one?
It just says select all the true statements. It's number 4.
About the line? Or the
Yes. Well, about the line.
About the function. It's a linear function. Some input values are integers.
Yeah.
False.
Jocelyn?
Yes.
No. Okay?
What's an integer?
What is an integer?
It's
A whole number including
negative.
negatives, right? So integers are whole numbers that also include negative whole numbers.
So
Okay,
yeah,
and 0.
it is true, right?
Yeah. Of course. And it's going everywhere in between too, right?
True.
Let's see. Some output values are integers.
No.
Some y values are
Positive
integers.
and negative.
Oh, yes.
Because if you look
There
at
will
A
be an
and
output
B,
value. No.
Yeah.
No, well, yes.
This one says there will never be an output value of 0.
Wrong.
That's false.
Wrong, because there's one right now.
What's the output value?
The
Output?
X.
Y.
Oh, Y.
Okay. So y0 is up here, right? On the y-axis, it's up here. So it kind of looks like it's really far away from the line. Well, watch this. We agree that this line has a positive slope and it is continuing, right? Even if the graph isn't shown, I could extend this x-axis all the way out here or further. And let's see, 0, 2, 4, 6, 8, 10, 12, 14, right? Eventually, this line is going to continue in this direction and continue on, right?
it looks like a stock.
Right
stock
on the
I know,
graph.
it's a terrible line, but I'm doing my best,
It looks like
okay?
stock market graph.
At some point, is this line going to have a y value of 0?
No.
Yes.
No.
What's the y value right here?
0.
14.
What would this, that's on the x.
But
2, 4, see the x? 2,
A y value,
4,
sorry.
6, 8, it's okay, 10, 12, 14. So that would be 14 on the x, and how
0.
far up or down?
0.
No far up or down, so the y value would be 0.
Unidentified.
Therefore, this is
Wrong.
false.
Wait,
So basically,
like,
it's just all of them except the E.
it's unidentified, right? Because it's just going straight up.
What do you mean it's unidentified?
Like that straight line that like you use for like that thinking power.
What?
You know.
It's invisible, is that what you mean?
No, no.
Okay.
You get my point.
I do. Get it? Point.
No. No.
You're welcome. I've been doing that.
You know, since I made that joke, I should get a
I've been doing that for
Wrong.
a high
You
five.
know what the class average on?
Maybe I'll give you a high five later.
I have a
See, I
question.
didn't ask for a taller answer.
Do you have any seat? Do you have any seat?
We don't need scissors right now, we're just taking it. but maybe later, okay? I've got a bunch more to do, you guys need to pay attention. Yes. No more bathroom after this.
Just making sure, ma'am.
Can I?
What? Oh, yeah.
We're not doing that right now, okay? So we have an equation. This did come up as one of the answers, one of the questions that a lot of people got wrong.
Yeah. I was like, how do you solve for that? -5.
But it kind of scared me because I have actually, this isn't like, hey, did you guys learn this last year? Like, I just spent like the entire last chapter on this stuff. And like the first chapter too.
Really bad with fractions.
Negative
Was it? Why are you guys so scared of fractions? They're smaller than.
I don't know what to do with them.
Negative 1.25, right?
I just don't know what to do with them, so I just.
It's like, that's the problem, they're smaller than
It's
the.
like,
Technically, yeah, this one is.
I didn't know if we were allowed to convert it to 1.25.
You are.
Negative.
You are, but you can't rely on that because there will be some fractions.
To have rectangle.
Yes,
And
exactly.
also it's scary because 15 divided by 0.5 equals 30. Like,
Yes.
that makes no sense.
Yes.
And you have to do
Oh, I'll
certain
get
things.
there. I will
Like-
show you how much sense it makes, I
It doesn't
promise.
make
You
any
guys crack me up because you're not the only class that like freaked out about 15 to, okay.
Like, I thought my
I'll show you
calculator
right
was
now.
broken
You guys
today.
freaked out that 15 divided by 0.5 is 30, okay? You're like, no, but 15 times 2 is 30, right? Watch this. 15 divided by 0.5 equals 30. You want me to prove it?
That's how many.
15 divided by, what's that as a fraction? 1/2
That'd be
equals
7.5.
30. You wanna know why? 15
No.
times the reciprocal, 2/1. Keep,
Change,
flip.
flip.
Kentucky chicken fried.
When you're dividing by a decimal, a number smaller than 1, fraction or decimal, you're actually making the number bigger. When you're dividing by a whole number, you're making it smaller. When you're dividing by a number that's less than 1, you're actually making it bigger. Okay?
Why?
Can I
Negative.
continue with this so I can get through all of these? No, I don't need hands raised right now. I really need focus. Okay. How do we solve this? What's the first step? Yes, Antonio? Good. Add 2 to both sides. -5/4x equals 10. Whoever's making that humming noise, stop it immediately. Thank you so much. Okay, next, what do we do? Yes.
Wait.
You multiply 4 over -4 over 5.
You multiply by -4/5. We're multiplying by the reciprocal. Very good. X is being multiplied times this. We know we can cancel it out by multiplying by the reciprocal because what we're really doing is dividing this by itself and then keep change flip.
Basically.
Okay.
And the crossing method too.
Now, since we do it on this side, we're gonna do it on that side too. So -4/5 needs to be multiplied over here. Whoops, it's supposed to be like this. Okay, so then I cancel my 4s, cancel my 5s. My negative times a negative turns into positive. Now it's gone. It's 1x, which is x. And then I have 10 times a -4/5. I can cancel out my 10 and my 5 to be 2.
Over 1.
2 times -4 is
-8.
-8. That's the answer. Jack, we
Over
go.
1.
I think
Oh, sorry.
I think I still got that, but like
I think
Somehow not.
Emily doesn't like you anymore.
Why?
And she just made a face. She said,
Do a race party.
She-
Oh, sorry. I stopped.
you did
Uh,
math.
You should be able to fill that in.
It was -4
You did
over
not.
5. That was the race part.
Absolute
face.
value.
the face. She,
Oh,
If you would like a more, were you still copying it? You can get from me. If you would like a very in-depth explanation of absolute value, who was in my intensive math class today? Did I explain absolute value like a 10-minute explanation of absolute value, right? So, I'm gonna give you the shortcut version because I want to get all of these in before the period ends. I want them on video. If you want the long explained version, Bo, no. Okay, that rhymed. The shortcut version is, the first thing we're gonna do to solve this equation is what? Lily? add 7 to both sides. The negative 7 isn't involved in the absolute value, so we can just treat it like a regular equation in that regard. 7 equals absolute value of 2x minus 1. Now,
Boom.
Wait, what?
here's the short. The negative 7 was outside of the absolute value.
Yeah, but like, I thought you could like distribute.
What is there to distribute?
Nothing.
It's not
The
from
seven.
No, the 7
is
is
the
being,
one.
the 7 was being subtracted from
Because
that
it's
number.
not that.
It would be a negative.
I need to be able to continue or else we're not gonna get through this.
I don't understand why I got those wrong now, because I was like so confused.
Yeah, so that's step 1, the easy part. Here, we're gonna split this because absolute value, you just gotta keep awake because you need to stand, okay? Absolute value needs a negative version and a positive version of this, okay? So, again, I explained this more in depth in my other video where I do the rest of these, but this one, I'm just gonna show you that you can take this and you have to make 2 separate equations. To break this free from absolute value, you have 2x minus 1 equals 7. That's your first one. Super easy, right? It looks just like that. This one is going to be 2x minus 1 equals negative 7.
Wait, why don't you?
If you don't understand that, you have to watch my other video. I've explained it in class. So this isn't something where I have to fill in a gap from what you didn't learn last year. I have already taught it in a whole lesson. So you can watch that video, or you can go to my intensive math video and watch that. I cannot explain that again, okay? This is the shortcut. Now we just have to solve both of these equations. Super easy, I'm gonna go really fast.
Ready?
Add 1 to both sides. 8 equals 2x. Divide by 2 on both sides.
4 equals x.
4 equals x.
And
That's
then
one
negative 4
answer.
equals
Plus 1. Negative 6 equals 2x. Divide by 2. Negative 3 equals x.
Ka-chow!
Good job.
See that? Oh my god.
Time is low.
You don't have to worry about what time it is. I promise I will dismiss you when it's time for you to leave class, okay? You guys don't ever have to worry about what time it is, all right?
Time for lunch.
Time is it? This time for lunch.
Carmen, what did you do?
Line up, everybody, line up.
Line up,
No.
outside.
Bubblegum bitch.
All right.
Favorite show right there.
Which of the following expressions has a linear graph with a slope of with a slope of 2/3 and a y-intercept of -2? The problem with these answer choices is they're not really in slope-intercept form. This one is. This one's in slope-intercept form, and we can easily eliminate it. Why?
Cause that's the one that stands out.
Because it looks like it's non-existent. The scope is in the box.
Yeah, the slope here says -2, but here it says it's supposed to be 2/3. That's not right.
They're
This is
trying to
wrong.
whip us.
To save time, I'm gonna skip to the correct answer and explain why it's correct. I am going to say that this is very close to being in slope-intercept form. Very close. What would I have to do to make this in slope-intercept form? Yeah.
So you would just put your 2/3x and just swap it with negative.
Yeah. Now I'm allowed to do that because this term and this term are being added together. Commutative property of addition. I can do switchies. So I can convert this to y equals positive 2/3 times x minus 2. Does that match up?
Yes.
Slope of 2/3, y-intercept of -2. And A and B are both wrong for various reasons. Okay. All right, I think I'm gonna be able to get through all of these if you guys don't mess around too much, okay? What is an equation in slope-intercept form of the graph? Sure. So it's setting it up for you. You just need to fill in your rise over your run and your y-intercept. Guys, we did this together a lot. And there were still a lot of wrong answers on this one. Bo, I will ask you to step out
I'm sorry.
because it's getting excessive, okay?
I'm so sorry.
Thank you. Now I have to fill in my rise over my run and my y-intercept. I don't know about you, but I have one that I like to fill in first. What do you think that is?
Y-intercept.
The y-intercept, because that is like pinpointed on my graph. The slope I have to like count and down there. I like to pinpoint something first. My y-intercept, boom, it's
Six.
right in front of my face,
What
it's
was
positive
hardest to
6.
tell what was the like X and Y because they were like the same. They
What?
were like bold. The X and Y axes weren't bolded, so it was like.
Oh, on this test?
Yeah.
Oh, that's
kind of
annoying.
hard to tell.
Oh, yeah, I see that, because it's like, yeah, you have to go by like the arrows and the whole X here. That is tricky. Okay, so, but technically they give you your points here, so you can just count your rise, 1, 2, 3, positive 3, and your run, 1, 2, 3, 4. Positive 4, because you're running to the right. So your rise is 3, and your run is 4. Obviously, it's going to be a positive fraction, positive slope, going towards positive infinite. Does that make sense? Yeah?
So what happens if a slope looks like 0? Like how would that work?
A slope of 0 is a horizontal line.
No, but I'm just saying, like, what would happen if they actually had an equation?
They wouldn't give you this if the slope was 0, I
They
promise
wouldn't?
you. And if they did, I'd,
Right.
have to, no, I would have to
I wouldn't be surprised if
write
you
a
looked
strong
at that.
letter. Yes?
I knew the answer, I just accidentally put it.
No big deal.
I accidentally put 4 first.
No big deal. Okay, this one cracked me up. I've already talked to the company about how this was ridiculous. Why is there such a huge answer box for
Why does it look like a sword?
negative? Right? I know, it's like, why does the negative box need to be so long? Complete an equation in slope-intercept form for a line that passes through 6, 5 and is parallel to this line, x plus 3y equals 9. This is in what form?
Slope intercept form.
No,
Standard.
it's in standard
Alright.
form. We're gonna convert it to slope-intercept form because this is in slope-intercept form, okay? So we're going, what do we do to convert it to slope-intercept form? What do we solve for, Charlotte?
Oh wait, hold on. Can you say the question?
Okay, I have this in standard form. To get it into slope-intercept form, y equals mx plus b, I need to rearrange this. What am I gonna solve for? To rearrange it. Nope. Take a look at slope-intercept form and what it is solved for. Slope-intercept form is solved for what?
X.
Yes, because the y is by itself. It is solved for y. Do you guys get that when there's a variable by itself, it is solved for, Jack, wake up, it is solved for that variable. So if this is solved for y, and this is solved for y, we want to solve this for y. Does that make sense? Okay, so to solve it for y, what can we do?
So we isolate the X, like we take.
We're gonna isolate the y.
Yeah,
I'm actually just gonna breeze through it. Okay, I have to isolate the y. 2 things are happening. I'm gonna get rid of the x first. I'm gonna subtract the x on both sides because the x is being added. I'm gonna subtract it. Cancel that out. 3y. No. I know, but it's distracting. There's no reason to be doing that while I'm trying to finish this.
Negative y.
3y equals
Negative
9 minus x. But I'm actually gonna switch these. I'm gonna do negative x plus 9 because I can, because of the commutative property of addition. And I want my slope first and my y-intercept last, okay? Divide by 3, divide this entire thing by 3. Cancel out your 3 over 3. Y equals negative what?
3x.
I'll help you.
Negative 3x.
X plus 9.
Negative x.
Negative, wait, it's.
I have to divide both of these terms by 3. What is this?
Negative x plus 9.
Thank you, negative 1/3, see? 1 over 3 times x.
Oh, I
Plus
thought that was a
3.
actual value.
We need a line that is parallel to this line, right? It's the same line, just rearranged, solved for. Oh my gosh. Go take a walk for a second. Go to the bathroom, go do something. I'm serious, just go. You're not in trouble, just go. I need to be able to finish this. Go take a walk, okay? All right, so y equals negative 1/3 x plus 3. This is the exact same line as that. It's just standard form, slope-intercept form. We need to write the line that is parallel to this. What can I fill in so easily, Vincent?
Parallel, negative 3 or 1.
Yes, same slope. right? A parallel line, so I need to put a negative here, so I guess I'll make my negative this big.
Negative 1/3.
That was supposed to be funny. Negative 1/3, they made the box that big, so I made my negative that big, is that weird?
Why did they do that?
I don't know. Now we just need our
Why you
y,
made it that
we need our y-intercept. Should I use a 3?
Yes.
No,
What?
because they said write an equation that's parallel to this line. Same slope, different y-intercept. Simple way to get that y-intercept is b, right? Take your point, which represents a point on that line, on this line, and sub in for your x and your y values. So y is 5 equals negative 1/3 x. I'm sorry, x is 6 over 1 plus b. Cancel, and I've got 5 equals negative 2 plus b plus 2 plus 2, 7 equals b. Okay?
Nice.
So now we have 7 is our b. Same slope, different y-intercept. That's parallel lines. Okay, I have 2 more. You guys will stay. If you, okay, real quick.
6 over 1.
Because the point had an x value of 6, so I put 6 over 1 because I had to multiply times a fraction. You can do that with any whole number. When you're multiplying a whole number times a fraction, you just plop it over 1. So that you have a numerator and denominator. Okay, solve the equation for x. Super simple. 4 divided by 2 is 2. So you have 2 times x plus 2 equals 12. You want to know what else? Divide by 2 on both sides. Cancel, cancel. X plus 2 equals 6.
Why can't you cancel out the 2 in the parentheses?
Because it's protected by parentheses, and because it's involved in an expression.
It's a force field.
What?
It's a 4, not a 2. It was divided
No,
by
no, no,
2.
I canceled out, I divided the 4 and the 2 already,
No, but then
got a
why
2,
did you divide again?
because I'm
the
getting
other
rid of the 2.
the
I
other
divided by 2 on both sides to get rid of this 2. So now I just have my x plus 2 equals 12 divided by 2, which is 6. Subtract 2 on both sides, x equals 4. And you can always plug it back in to double check.
Why?
I'll say it again. I have 4 over 2 here. They're not caught up in parentheses, so I'm allowed to divide those. And that gives me 2 times x plus 2. I don't want there to be a 2 here. I want to solve for x, so I divide by the 2. Divide by the 2. You get it? I'm just undoing everything. Okay, I have 1 more, and then I will let you go, okay? If you try to pack up before I dismiss you, I will keep you longer, because I can. And I don't have to talk about this. I'll keep you as long as I... Oh, you know what? I'm gonna let you guys go because this question technically. Do you mind if I finish my sentence first? Do you mind? This question technically, we have already solved one exactly like it already in this period. Jocelyn and Dave, can I talk to you guys?
Hit him with the outro. Here we go. Adios, amigos.